Now let us consider the next task, circular motion in the horizontal plane. The first term that we need is nothing but angular displacement, angular velocity, angular acceleration, relations, and some important note. So these are the 5 point of discussions for the present class. Let us have angular displacement. Suppose an object is moving on the circular track from one point P to that of another point Q and makes an angle theta degrees at the center. In such a case, this happens in the interval of time t at the center O. Now we said that the object changes its position radially by theta degrees, known as angular displacement. And you can measure angular displacement with units known as what? Radians. Second one is angular velocity. So, angular velocity. Angular velocity is represented by the symbol omega. This is a best example for axial vector. Always acts along the direction of a rotational axis. It may be real or virtual. Okay, no problem. Depending on rotational axis only or direction of rotation axis only, omega bar will be present. Anyways, the angular velocity is defined as the rate of change of angular displacement. This is known as instantaneous angular velocity. And we have one more formula, average angular velocity given by theta final minus theta initial by T2 minus T1 we can use for average angular velocity. And a part of these two formulas, we have omega is equal to 2 pi f and we can add on as 2 pi by t, where f is nothing but frequency of rotation, t is nothing but time period of rotation. You can write down angular velocity and time period of rotation. F is nothing but frequency of rotation. In this particular case, now let us consider the next case, angular acceleration. Angular acceleration. Now, the angular acceleration, nothing but symbol alpha. This is defined as the rate of change of angular velocity. So it is defined as rate of change of angular velocity. And this particular thing also equal to omega final minus omega initial by t final minus t initial. This is applicable for instantaneous calculation. This is applicable for average calculations. The angular acceleration alpha, this also belongs to the category of axial vector. Axial vectors are also called as what vectors? Non-polar vectors. Non-polar vectors. Anyways, the unit of measurements are here nothing but radian per second square. You have to be taken. Now, after angular acceleration, we have the next term called as some important relations. Let us see one by one the important relations. First relation is tangential velocity vector Vt bar is always equal to omega bar cross r bar. and tangential acceleration is equal to alpha bar cross r bar. We can write down second relation. Third relation is we can write down as omega is equal to of important step 2 pi f, which is equal to 2 pi by capital T, and you can write down as this formula also written as delta v relative by delta r. We can write down delta r is nothing but what here, radius. We have to take common radius, or r relative. You can take any word you can get set here. Next, suppose if we consider angular displacement d theta, that is given by 2 pi into n, where n is nothing but any fraction you can take, a full integer or any fraction you can take, number of rotations that is represented by this particular formula. Fifth, if omega bar is parallel to that of alpha bar, number of rotations increases. If omega bar is anti-parallel to n bar, then number of rotations are decreases in this particular case. Next, when number of rotations are increases means frequency increases, here frequency decreases, the standard result. Then another important relation is omega value depends on rotational axis and origin of rotation. Okay, depending on these two parameters, omega will change. Next important relation is Vt bar perpendicular to r bar, Vt bar perpendicular to omega bar, omega bar perpendicular to r bar. Means what you write down here, their dot products are going to satisfy these results. Similarly, you have tangential acceleration at bar perpendicular to that of what you write down here, radial vector, and at bar is also perpendicular to alpha bar, and alpha bar is also perpendicular to r bar. In such a case, what we write down it is at bar dot r bar is equal to at bar dot alpha bar is equal to alpha bar dot alpha bar is equal to, you can write down as what, 0. We can write down the given problem. And further, one can develop the rotational equations as per like this: omega initial is equal to omega final is equal to omega initial plus or minus alpha t. We can write down delta theta is equal to 2 pi into n is equal to omega I into t plus or minus of alpha into t square. Omega final square minus omega initial square is equal to, you can write down as 2 alpha into delta theta, which is equal to, you can write down as 4 pi n alpha. So with any one of the possible equation we can identify. And further, in the 12th case, during the uniform and as well as non-uniform, what is the difference? In the uniform circular motion, we have tangential acceleration is 0. In the non-uniform acceleration, tangential central both are present. That means net acceleration is equal to only AC only present. Here net acceleration is equal to root of AT square plus AC square you have to write down. Why I wrote like this? Because at any momentary time you can take AT bar perpendicular to always AC bar, means AT bar dot AC bar is always equal to what? 0. You can write down. And when try to represent in the form of a small image, so this is the direction of AC. Any direction you can take. Always these are the position of objects. Always directed to the center. That's the nature of AC. And in case of non-uniform motion, when you consider, take any point, this is the direction of AC. Perpendicularly, we have what here? 80, we can write down. Therefore, when two vectors are isolated by 90 degrees, and this will become net acceleration A net. So, the value of A net in the problem is given by A net. Already we have this formula. If A net makes an angle alpha degrees, then the value of tan alpha, let us take here tan alpha. So the tan alpha is equal to, okay, if you're getting any confusion means prepare this one as something like a theta here. So tan theta is equal to, you can write down as AC by AT, we can write down. So using this formula, one can determine the value of theta in this particular case. And in this particular condition, force acting on the system called a centripetal force Fc, which is equal to m into AC, we can write down. In this case, net force acting on system is equal to m into A net, you have to write down. Why? Because this particular system experiences two force accelerations. Therefore, this value will be equal to, you can write down as ftc square plus fc square, you can write down. Ft square means a tangential force square, and this is centripetal force square, where centripetal force is nothing but MAC, or which is also equal to mv square by r, we can write down, or which is equal to mr into omega square. All the symbols are standard, means representing what? Fc only in the given case, right? Now let us try to consider some simple cases. Centripetal force Fc is equal to, you know that the formula mv square by r, we can write down as what? Mr omega square, you can write down. Now in the given case, what happened? Fc proportional to v square and proportional to 1 by r, and this is also equal to omega, means you can write down 4 pi. Therefore 4 pi square m r by, you can write down as a t square, you can write down like this with a simple case. Now after completion of this, we got Fc is equal to Fc proportional to v square, Fc proportional to 1 by r, and Fc proportional to, provided that 1 by t square. Depending on the case, we can plot the different type of graphs for this particular situation. And next thing is 15th one. If you try to consider selectively the value of AC, sometimes it is also called as radial acceleration. Centripetal acceleration also called as radial acceleration. Abbreviation only different, and working will be same. We know that AC is equal to, centripetal acceleration is equal to, you can write down as v square by r. As v is equal to, you can write down what? R into omega square, you can write down. And instead of omega, you can write down, if you write down 2 pi f of frequency, then what we write down here? 4 pi square into n square. N means number of frequency here, n square into r, we can write down. This is the centripetal acceleration. Therefore AC proportional to f square, provided that r is equal to fixed. These are the standard abbreviations we have to take care. But in case of sorry, you please take it as 14th one, and please take care of this is as a 15th point. Now in this particular case, suppose if we consider perfectly in the non-uniform motion, I need the net acceleration. Net acceleration is nothing but what you can write down, AT bar plus AC bar only now. AT bar means what you write down here, R alpha bar. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.